Hi everyone, this is Amy from the Helms Academy, and today we'll be doing our Math Roundtable recap from October 8th, 2020. So we always start off with the important steps. So first, we always need to highlight or underline the important information in the problem. And then we can determine which operations are needed. Do we need to add, subtract, multiply, or divide? And then we can write out the problem using the numbers in the operations, and we're able to solve it. Let's look at problem 1 today. Susan traveled 114 miles in 2 hours. If she keeps going at the same rate, how long will it take her to go the remaining 285 miles of her trip? So we're going to use the information they gave us here to create a proportion because we're comparing one amount of distance in time with another amount of distance in time, and they should be moving at the same rate. So how do we set that up? Well, you'll see the parts in blue and then the parts in red. So those different parts help us to figure out where to put everything in our proportion. We know the 2 and the 114 go together as part of one fraction as we write it. So we'll make sure that those two are together, but parallel to them, we need to make sure that the number of hours is parallel to the 2, and we don't know that, so we put an X. And we need to make sure that the other mileage is next to the 114. It's parallel there. So that's why the 285 is beneath the X. So if we put all that together to get our answer, we need to cross multiply and then divide, which means we're doing 285 times 2 divided by 14, and that gives us 5. So the final answer is that it will take 5 hours to go the remaining 285 miles of the trip. For word problem 2, we see Allison baked a cake for Guy's birthday. 4/7 of the cake was eaten at the birthday party, and the next day, Guy ate half of what was left. How much of the cake did Guy eat the next day? All right, so you can see on the screen there, I have put a circle that's cut into 7 equal pieces. For the sake of this, we will count them all as equal. So in that, if we're looking at that and we think that 4/7 of the cake was eaten at the birthday party, then we need to think about what's left. So if we remove 4 of these slices, of the 7 slices, we're only going to have 3 slices left. So at this point, we know there are 3/7 of the cake remaining, but we know that Guy ate half of what was left. So let's put that information together. First, we need to take our 3/7, what's remaining, and divide it by 2. Now, we know that dividing by 2, when we're talking about fractions, is actually the same as multiplying by the inverse. So instead of divided by 2, we can do multiply by half, and that's even easier because in multiplication for fractions, you just multiply across the top and multiply across the bottom. So that means 3 times 1 is 3, and 7 times 2 is 14. So the answer is that Guy ate 3/14 of the cake the next day. For word problem 3, it says the quotient of 3d to the 5th and 9d to the 3rd is... So we need to figure out some of the language here. What do we mean by quotient? Well, quotient tells me that we're dividing. So we're going to write this out as division. 3d to the 5th divided by 9d to the 3rd. Now, you might notice that this looks a lot like a fraction. That's because fractions are also, in their own way, a form of division. So if we look at this, we now need to simplify it. First, we can simplify the whole numbers here, and then we can simplify the exponents. So 3/9. I know the equivalent of 3/9 is 1/3. That's the simplest form of 3/9. So I'm going to go ahead and simplify those numbers down and change that to 1/3. So now I have 1d to the 5th over 3d to the 3rd. Now, if you remember from before, anything times 1 is just itself. So I can really get rid of the 1 that's on the top there. So I'm going to keep that in mind for my next step. Now, the rules of exponents say that when you're dividing two like figures with different exponents, that what you can actually do is just subtract the exponent values from each other. So if we think about it that way, we have d to the 5th and d to the 3rd. 5 minus 3 is 2. So that leaves us with d squared. So the way that we'll write that is d squared. So we move all of the d up to the top there, and then we keep the 3 on the bottom. And remember, we did not need to carry the 1 over here. So our final answer is d squared over 3. For word problem 4, it says Al is painting a cylinder storage tank. In order to purchase the correct amount of paint, he needs to know the total surface area to be painted. Which formula will he use if he does not paint the bottom base of the tank? So this has a number of pieces to it. First, we need to know the cylinder shape. We're working with a tank here. So if you think about a cylinder, it has a circle on the bottom and a circle on the top, and then everything that goes down in between. So he has a cylinder shape, and we also know we're looking for the formula, not necessarily the answer here, but just the formula for how to find the answer. And we need to do only part of the formula because he's not going to paint the bottom. Makes sense, right? If you're painting a big storage tank, you may not paint the very bottom of it. It's going to sit on the ground. So it's a practical question. How would we put that into a formula? So if we look at the surface area and volume of a cylinder, the area of a circle, these are all things that are on the GED prep sheet for math. So you can actually access this before you go to the test, and you will also have access to it during the test. This is your formula sheet. So the cylinder, we see surface area equals 2 pi RH plus 2 pi r squared. So with the circle, we know that the area of just the top or the bottom would be pi r squared. So I want you to think about it this way. The surface area of a cylinder, that 2 pi r squared, is the two circles on the top and the bottom. And the 2 pi RH is the area around the cylinder this way. So if we only want to do one, just the top, and not the bottom base, then we don't need to say 2 pi r squared. We just need 1 pi r squared. And we can keep the rest because we do need to know the area around the cylinder. So if we put all that together, we would just have pi r squared, so just one of those for the top, and then the 2 pi RH, which is going to show us the rest of the surface area around. Just as a reminder, all of these things have different meanings. So for example, r stands for the radius, which is the distance from the middle of the circle on the top or bottom of the cylinder to the outer edge. Pi is 3.14, and h stands for the height of the figure. So it's really good to get familiar with the different things that are on the formula sheet and the things it might be asking you to understand before you go to the test, because for this one, again, we didn't have to solve this. We just had to know a bit about what's on the formula sheet so we could put together the pieces and solve it this way. For our last one, word problem 5, we have Audrey measured the width of her dining room in inches. It is 150 inches. How many feet wide is her dining room? So this is a conversion problem. We need to think about how many inches are in 1 foot. So we know that there are 12 inches in 1 foot. So if we divide 150 inches by 12, that tells us that we'll have 12.5 total feet. So the dining room is 12.5 feet wide. Thank you so much for joining me today and for solving these problems. I hope you learned something new, and good luck on your journey to finishing your GED, TASC, or HiSET math test. You can check out more of our videos and subscribe to our channel below, and you can also find us on Instagram, Facebook, and at helmsacademy.org.